So for this problem, to find the integral using trigonometric substitution, then from this given, so first, we need to check the pattern. So since from this given, we have 4 minus x squared, so the pattern is a squared minus u squared because a is a constant. Then from this pattern, we let u equals a sine theta. So first, we need to solve for a and solve for u. So to solve for a, so we have 4 equals a squared. Then take the square root to solve for a. So therefore, a is equal to 2. Then to solve for u, so this is x squared minus u squared. Then to solve for x, so take the square root. So therefore, x equals u. Then since we let u equals a sine theta, so we have x equals a, and a is equal to 2. Then sine theta. Then find the derivative, so the dx equals, bring down the constant, and for the derivative of sine theta, that's equal to cosine theta. So we have 2 cosine theta d theta. Then apply now the trigonometric substitution from this given. So this becomes the integral of x, and x is equal to 2 sine theta din times dx, and dx is 2 cosine theta d theta din over the square root of 4 minus x squared, and x is 2 sine theta, then to the power 2. Then to simplify, so we have the integral. So multiply this 2 times 2. This is 4. Then sine theta, cosine theta, d theta, then over. So this becomes the square root of 4 minus this 2 squared. So this is 4. Then sine squared. So we have sine squared theta. Then to simplify, so this becomes the integral of 4 sine theta cosine theta d theta din over the square root. So we can put this common 4 outside. So we have 4. Then this 4 divided by 4, this is 1, then minus 4 divided by 4. So the remaining is sine squared theta. Then this becomes the integral of 4 sine theta cosine theta d theta din over. So the square root of 4, and this 1 minus sine squared theta using this identity. So that's equal to cosine squared theta. So this is cosine squared theta. Then this becomes the integral of 4 sine theta cosine theta d theta over the square root of 4 is 2, and the square root of cosine squared theta, this is cosine theta. Then we can cancel this cosine theta and cosine theta, and this 2 and 4, so we still have 2. Then we need to put these two constant outside, so this is 2, then the integral of sine theta d theta. Then to evaluate now the integral of sine theta, so we have 2 times the integral of sine theta is equal to negative cosine theta, then plus c. Or this is negative 2 cosine theta plus c. Then this time, we need to find the value for this cosine theta. So to solve for cosine theta from this x equals to sine theta, so from x equals to sine theta, so to solve for sine theta, divide both sides by 2, so therefore sine theta equals x over 2. Then we need to make a right triangle, and this is our angle theta. So opposite to the angle theta is the opposite side. This is the adjacent, and this one is the hypotenuse. Now take note, since sine is equal to opposite over the hypotenuse, so therefore this side is equal to x, that's the opposite, and this side is equal to 2, so therefore the adjacent is the unknown. So from this right triangle, using the Pythagorean theorem, since h, or the hypotenuse, is equal to the square root of the opposite squared plus the adjacent squared, and to solve for the opposite, this is equal to the square root of the hypotenuse squared minus the adjacent squared, and to solve for the adjacent, so this is equal to the square root of the hypotenuse squared minus the opposite squared. So therefore, to solve for the adjacent using this formula, so this is equal to the square root of the hypotenuse squared, and the hypotenuse is 2, so 2 squared, this is 4, then minus the opposite squared, and the opposite is x, so this is x squared. So the adjacent is equal to the square root of 4 minus x squared. So we can find now the value for cosine theta, because cosine theta is equal to the adjacent over the hypotenuse, or this is equal to the adjacent, the square root of 4 minus x squared, then over the hypotenuse, that's 2. So cosine theta is equal to the square root of 4 minus x squared over 2. So this time, substitute now this value to this cosine theta. So this becomes negative 2, then times the square root of 4 minus x squared over 2, then plus c. Then to simplify, so we can cancel now these 2. So we have now negative square root of 4 minus x squared plus c.